And we've entered the land of derivatives, which is sort of calculus for real. This is homework 3.2. I wanted to go through, let's say, one of these questions, just so you sort of see what's going on. For part A, they ask you to use the definition to find f prime of x. When they ask you that, what they mean is this. They mean limit h goes to 0 of f of x plus h minus f of x over h. So this homework problem intends for you to find the derivative of 1, 2, 3, 4, at least these first four, using the definition. I'm not going to do that. I think that you can probably handle that without going over it. But like, for example, you did this, I think even on one of the quizzes, where f of x was x squared. And you were told to find the limit as h goes to 0 of x plus h squared minus x squared over h. And, you sort of do it, and the answer is, it cancels down to 2x plus h. And then finally you say that's 2x. Little did you know at the time that you were actually computing f prime of x, which is 2x.
Yeah.
Okay. So that's what it means when they say definition. That's not what I'm going to do for these problems. So just picking one. Let's do number 4. Okay? So for number 4, I'm going to do part A. If f of x is, what, x cubed minus 4x, f prime of x is, well, let's zoom in on it. Uh-oh. Zooming craziness. We've seen the way derivatives work. This 3 comes down in front and is replaced by a number that's 1 less than that. So the first order of business is 3x squared.
Yes.
Minus is still minus.
But 4x changes. That will be just 4.
There you go. Okay. F prime of x is 3x squared minus 4. Easy stuff, right? As it turns out, let's see here. The second part, find the domain of f prime. There's nothing tricky here because we're not into those fractional exponents where I end up with 1 over 2 root x. So the domain of f prime of x is everything. Because it's this function which has no restrictions. All right. Find an equation of the tangent line to the graph of f at p. So the p in question is right here, 2, 0. Okay? So our point is 2, 0. And our slope will be the slope of the tangent line at this point, which is going to be f prime of 2.
Yeah.
In other words, I plug in x equals 2 into our formula up here that we just found for f prime.
Yeah.
Okay. Now, if we were asked to use the definition, we'd have to do something different. But anyway, f prime of 2 is what? 3 times 2 squared minus 4, also known as, let's see here, 3 times 4 minus 4 is 8. Okay, So find an equation of the tangent line at the point 2, 0 with a slope of the tangent line 8. The rest of it is simple. Y minus 0 equals 8 times x minus 2. This is just point slope form, right? So we could say it's y minus f of a equals f prime of a times x minus a, where a equals 2. This is my y-coordinate. It's f of a. My slope is f prime of a. And then my x-coordinate is a. In other words, this point 2, 0 is the point a, f of a. If I plug in 2 to my original function, f of 2 equals 8 minus 8, which is 0. All right, so we found the derivative. We found the domain, which is everything. We found the equation for the tangent line by plugging in 2 into the derivative to get the slope, and then we use the point 2, 0. Last thing they ask us to do, find the points on the graph at which the tangent line is horizontal. So I'm going to go down. I'm going to rewrite my derivative. F prime of x was 3x squared minus 4. Okay. Horizontal tangent line means that f prime equals 0. Okay? So that means I just solve it. I say 3x squared minus 4 equals 0. And of course, you can fix the radicals if you want.
Right? Re-education program.
Yeah.
Yeah.
So anyway, the points on the graph are 2 over root 3 and then f of 2 over root 3. And negative 2 over root 3, comma, f of negative 2 over root 3. And of course, to get f of 2 over root 3, I have to plug it back into x cubed. 2 over root 3 cubed minus 4 times 2 over root 3, and who knows what that is. But that's the y-coordinate. Okay? Summing up, what did we do? We first used the rules to find the derivative, then we found the equation for the tangent line, then finally the horizontal tangent is exactly where the derivative equals 0. All right.